Okay, welcome back to WSHS Algebra 1 Virtual Tutor. The lesson that we're going to learn today is about dividing exponents. So last lesson, the objective before this, objective 12, what you learned was how to multiply exponents, or multiplying one term by another term, and having variables and coefficients and things like that. So with multiplying, you learned that you would multiply your coefficients and add your exponents. Well, with dividing, we're going to actually work in a different route. So with dividing, what we're going to have to do is divide our coefficients and then the powers with the same base, what we do with those is subtract those exponents. So with multiplication, you would add the exponents, right? And division is the opposite of multiplication. So instead of adding exponents, we're subtracting exponents. That's where we get this from. So I'm going to go ahead and do example 1 and kind of write it out the long way so you can see why we're able to subtract. Okay, so what we're doing here is this example says we have x to the third power divided by x to the fifth power. So whenever we see that fraction bar, that does mean division. So how many x's do I have here if it's raised to the third power? Well, that's saying I have 3 x's in my numerator. And if it's raised to the fifth power in my denominator, that's saying I have 5 x's in my denominator. Okay, so anytime you have the numerator and the denominator that are the same, so if I want to pair this up like this, I could say that x divided by x, or anything divided by itself, is actually equal to 1, right? So this would actually cancel out. So that would cancel. So we can kind of pair them up like this. This would cancel out, and this would cancel out right here. So how many x's did I have altogether? If I look at the ones that did not cancel out, I have 2 x's left over. Right? So that with it, if there's 2 x's here, then technically the exponent is 2. So that would be x squared in my denominator. But I don't have anything left in my numerator. Nothing left in the numerator, we actually wind up putting a 1 there. So my answer would be 1 over x squared. Okay, so that's doing it kind of a long way, but as the exponent starts to get larger, it'll take a lot of time to write them all out like that. So the rule, the shortcut here is this property, quotient property, says what we can actually do instead of writing them out the long way is we can just take our base, right, which was the x, same variable there, and we can subtract our exponents. So we had a 3 in the numerator minus a 5 in the denominator. So what is 3 minus 5? 3 minus 5 is negative 2. And then we said from here, last time, we mentioned we can't have negative powers or negative exponents in my final answer. So what I'm going to need to do is actually move it to make it a positive exponent. So here's where we moved it to the denominator, right? Or we said we move it to the basement. It's the same idea there. So we're going to move that down to the bottom. And if there's nothing left over in the top, we put the 1. So same answer, just 2 different ways, right? So this is the shortcut here based on the quotient property. We want to do it this way. So x to the 3 minus 5 equals x to the negative second power. Can't keep negatives in our exponents, so we have to move it to make it positive and write our final answer. Okay, so the only way you move it again is if you had negatives as exponents in your final answer, because that's not allowed. Okay, number 2, example 2. Following along with this, we can say we'll take our bases and subtract our exponents, right? If I had a coefficient here, like a number in front of the x here, then I would divide those, but I don't have any. So here we have x to the negative 2 minus 3, right? Because I want to take these first together. And then for the y's, I can go ahead and say y to the 4 minus negative 1. You want to make sure you keep those signs the way they are, and you do have the subtraction between them because these were both division. So negative 2 minus 3 is actually negative 5, so this becomes x to the negative fifth power. Then 4 minus negative 1 is actually a positive 5. So that would make our answer x to the negative 5, y to the 5th power. But again, we said we cannot keep negatives in our final answer. So what we're going to need to do with this x to the negative 5 is actually move it to the basement or move it to the denominator to change and make it positive. So that will make our answer y to the 5th, which stays in the numerator because it did not have a negative exponent, and then x to the 5th in the denominator. Okay, let's try another example here. We have 24a to the 9th, b to the 10th power, divided by 8a to the 5th power, b to the 7th power. So this time we've got some questions in front of my variables here, right? I have 24 in the numerator, 8 in the denominator. So same concept here. We're going to go ahead and divide coefficients. Remember, we are dividing coefficients, and a coefficient is the number in front of the variable. And we're going to subtract the exponents. That's the rule here. So I have 24 divided by 8, which is 3, right? And then I'm going to take my a's. I have a to the 9th minus 5, because I'm going to take those two exponents, subtract them. 9 minus 5 is 4. And then I have b to the 10 minus 7. 10 minus 7 is 3. So this leaves my answer. I'm going to put it all together. 3a to the 4th b cubed. Now, I don't have to move anything here because I did not have a negative exponent in my final answer there. So no moving necessary. So this would just be my final answer here. Okay, example 4. Again, we have coefficients here, so we're going to go ahead and divide the coefficients. 7 divided by 28. And what's going to happen there is we're actually going to get a decimal. We wind up, if you're going to divide that in your calculator, you're going to get 0.25. Now 0.25, we can't leave decimals like that as far as our answer goes. We have to change it back to a fraction. Okay, so if you don't already know, some of you might know automatically that a quarter, right, is 1/4, 1/4, 1/4, 0.25. But if you did not know that, there's a way in our calculator that we can take our decimal, so 0.25, you can plug that in. Then you want to hit the math button, and then option 1, which says frac, because that would change your decimal to fraction. And then you hit enter. And that'll give you the 1/4 just in case. Okay, let's go ahead and look at our x's. We had exponents of 3 and 6, so we're going to subtract 3 minus 6, and that's going to give us a negative 3. Take your y's here. We have y to the 6 minus negative 4. Sorry, it's hard to see that there. 6 minus negative 4. And that's actually going to give you a positive 10. And then for my z's, that was my y's, for my z's, if there is no exponent there, technically it is a 1. We can fill that in with a 1. So that would be z to the 1 minus 1. Well, 1 minus 1 is 0, right? So this is saying that I have 0 z's left over. So there are no more z's, or you probably learned this last time, anything to the 0 power cancels out and becomes 1, right? So there are no more z's left over. So we wouldn't even write that down in my final answer. So if I want to put this all together, I have 1/4, right? Then I have x to the negative 3, y to the 10th. And then we can say here that the -3, remember we said we can't keep this here as my final answer, so I'm going to have to move this to the basement. Right now in the basement, in the denominator, there's a 4, right? Because my numerator I have a 1, and my denominator I have a 4. So I could actually take this x to the -3. It's going to join that 4 in the denominator and become a positive exponent. Okay, in my numerator, I have the 1, and I have y to the 10th power. So my answer could be written like this, 1y to the 10th over 4x cubed. Or most likely we won't see the 1 in front, so we're just going to make this y to the 10th over 4x cubed as my final answer. But either way, it would be correct. Okay, and that is how you divide monomials or divide exponents.